Happy Monday.
Happy Monday. How's it going, Joe?
Doing great. How was your Christmas?
It was good. It was very low key.
What do you mean by low key?
Meaning, I think I got up at 9 or 10 o'clock in the morning, got a lot of sleep. I didn't have any kids running around or anything like that. No nieces or nephews this year. So,
oh, that's awesome.
Yeah, just enjoyed some extra rest. Hung out with my mom and her husband. It was awesome. So, yeah.
Tell me what that would be like. So that's awesome. Yeah, I think I was up at 4:30 or something.
But aren't you always up at 4:30 anyway? I mean,
usually.
We're kind of on the opposite schedules, like we're in different time zones. Basically.
Yeah, exactly. So yeah, that's kind of how it is.
Yeah.
But anyway, originally we were going to have Luigi Petrino on. He just actually emailed and said he's woke up really sick. So
a lot of my friends are going, and we're getting back to like actually having colds and flus and other things. Although
that's a
lot of my
There's
friends,
no such thing as other illnesses.
Yeah. A lot of my friends also have COVID right now, so lots of stuff going around.
Luigi,
Yeah.
I hope to have you on at some point. Yeah. But I think we'll talk about the. We'll take a bit of it. We're originally going to talk about machine learning in production. I think we're going to take a bit of a slight detour and talk about data engineering versus machine learning engineering. So I think these two sometimes do get conflated with the other. They're not quite the same thing, but let's dive into it. And also, if you're in the audience, feel free to drop comments, ask questions, et cetera, et cetera. The usual way we do things.
Yeah. Troll us if you want, but hopefully not too badly. Tell us we're full of it, or we have opinions about these things. I mean, what are your general thoughts about the difference between ML engineering and data engineering?
Well, I mean, you got to look at it, I think, from the perspective of the life cycle, right?
Yeah.
So that's how I tend to view things. Life cycle, really, the data engineering life cycle starts from getting data from source systems, doing something with it, then making it available downstream to data scientists and data analysts and so forth. One of those end users may in fact be a machine learning engineer. They may take the data that you've produced and set up systems that I guess incorporate the data into the machine learning data lifecycle as well, right? So.
Yeah, and I think of it as a big Venn diagram with a ton of overlap in the middle because, quite frankly, often there are many ML engineers who just focus on like managing GPU clusters, for example. If you're at a really big company like Facebook, you have ML engineers that just focus on that one job. On the other hand, in a small organization, you may have ML engineers that do the entire life cycle all the way from ingesting data, processing, featureization, and then running models in TensorFlow or something like this.
Mm-hmm. Yep.
So
I think it really does depend on the maturity and kind of where that company is or that organization.
Scale.
Yeah, because you say the role could be sort of a hybrid role, and I think that's pretty realistic actually. Which means this engineer needs to know about a ton, right?
Right.
So GPUs, what type of hardware to use based upon a certain machine learning problem, et cetera, et cetera, et cetera. And I would say also having a good understanding of sort of the underlying stuff, even like how linear algebra works, right? And how that impacts hardware is. Yeah. I mean, we're both math nerds. You probably forgot more math than I've probably ever known.
I've certainly forgotten a lot of math. I can tell you. I don't use my representation theory that much anymore. So.
Walk me through that, though. What would be some of the, if let's take the thought experiment for a data engineer. What's some of the math that you think a data engineer should know to do machine learning, or to at least understand what's going on?
Yeah, it's interesting. I mean, one of the exams I really like in this domain is the Google Cloud Professional Data Engineer exam, because they do inject a lot of basic machine learning in there, the kind of stuff that data engineers should know. So, for example, they talk a lot about basic types of featureization, including things like one-hot encoding, where you take different features and you effectively just map them to linearly independent vectors, which sounds more complicated than it actually is.
It's rows and columns.
Yeah. It's just mapping to ones and zeros, basically.
Right. Super complicated.
Yeah, I mean, it's actually something. A lot of this stuff you can do in SQL. Even at some point, you outgrow SQL as a tool. But yeah, a lot of overlapping into machine learning engineering just comes down to your ability to communicate with data scientists and your more machine learning specialists who actually develop the models themselves.
Right. So yeah. It's kind of a classic question. I saw this stupid, and I called it dumb. It was a 2x2 matrix of it was a company assessing the skills that they thought data scientists needed. And it was like, math was not important and at the bottom, which I guess depending on their situation maybe, but
depends,
but the thing that irritated me was it also appeared in Harvard Business Review, where it could be interpreted that this is a matrix of data science skills. And so I don't know, I'm always a first principles person, so I think at some point like you do need to dive into the math and just understand how things work. But maybe I'm overcomplicating things, and the audience will probably agree with that statement. So, but it does help, right? So like I think certain the way code's written, for example, it could be more efficient. It could be less efficient. Like you could take advantage of packages that basically just vectorize what you're trying to do. So but knowing how that works, I think, is what I'm trying to say. It's I think blindly applying libraries and formulas and models is at some point I would say not advised.
Right. And you like to use the term cargo culting, right? And that is that people get into, say, a machine learning engineering role. They don't really know what they're supposed to be doing. They're just kind of thrown into this, which I think we both had that experience to some extent, being thrown into new teams. And the tendency is just to say, well, this company is doing it, so why don't we do it? Not realizing
there's a lot of this. Yeah.
If you're not operating at the scale of Facebook, say, then you probably are doing a lot less specialization. I mean, Google has engineers that just focus on one part of one system, and that's their whole career. And they're very, very good at that one thing. If you're at a small company, you can't do that, nor should you be attempting to do that. And you may find a lot of value from potentially complex algorithms, but often the value is in very simple algorithms, especially in kind of your phase one when you're just kicking things off.
Yeah, I would say start with data engineering too, right? Unless you're, it's sort of just the Monica Rigotti's data science hierarchy of needs, or the AI hierarchy of needs. Like machine learning's at the top of the pyramid for a reason. Most of the bottom is simply just the efforts that data engineering, is trying to solve, which is like data pipelines, storing data, transformations, et cetera, et cetera. That's more of a data engineering type of a problem because it sets you up to do an analysis, right? And analysis, I would say, 8 or 9 times out of 10 is where you should focus your attention first, get to know your data, get to know how data solves your problems versus jumping straight into machine learning. Because inevitably that engineer that's tasked with machine learning engineering, when they're not ready, they end up just doing data engineering.
Yeah, that's right. And I think recognizing the priorities in data engineering actually helps you to produce value. What sometimes happens in data engineering is people are thrown into these roles and they, first of all, overcomplicate things. Frankly, especially, a few years back in the peak big data era, there was a real tendency to overcomplication.
Well, give me some examples of that.
Well, so what we often saw is, companies would build out a Hadoop cluster, and it would turn out they didn't even have that much data to justify building a Hadoop
like a couple
cluster.
gigs or something.
Yeah, or even if you're talking terabytes, I mean that's
not that
really
much,
not that much. It's easier now, to be frank, but even back then you had tools like EMR that you could do off-the-shelf stuff with fairly easily. And after a while, it just became the Hadoop cluster had become this altar that everyone worshipped at. It's like you would have to spend all this time babysitting the Hadoop cluster, upgrading software, or doing ops on it. And there was sometimes a loss of focus on what the actual problem was that you were trying to solve or what the value of this data in this Hadoop cluster was. So that's the overcomplication part. And then the other thing we saw, and this goes back to what you were saying about analytics, that you kind of want to start there before getting into machine learning. If your data is not suitable for analytics, if the quality is not there, then it's also going to produce bad models when you train, and the model evaluation will be bad. So in other words, if there's corrupt data in there, there's like, for example, bot traffic that you're not able to filter out that's messing up your results, that will also, just as it messes up the human brain doing analytics, it's going to mess up any model that you try to train. And that's where you've got to focus on fundamentals and build a foundation before you can do anything really sophisticated. And in practice, that's often part of the machine learning engineer's job. But depending on where you set boundaries, it may be the data engineer's job. The data engineer may handle the early parts of the life cycle, get the data really clean, and then pass it off to ML engineers. Or again, at some companies may not even have the title data engineer. They may just call everyone a data ML engineer and handle the
pipeline. Yeah.
So,
I mean, it's a title that keeps people around.
Yeah.
I think I saw one stat where it was like ML engineers made like 1.5 or 2 times as much as data engineers. So
maybe we should just rename our company and rename everything.
We're just going into ML engineering.
That's right. Yeah. That's right.
But I would say that the number of companies that need ML engineering, if you take that subset, it's like data engineering versus ML engineering. I think data engineering is just much more in demand right now, just because, I mean, it just seems to be. Maybe we're just speaking, anecdotally, and we have a kind of selection bias as well, or but.
I think for us, and again, this may be a selection bias problem, but what we're seeing is the transition to the cloud is driving a lot of demand. I mean, a lot of our gigs are various types of transitioning to the cloud or building out new cloud infrastructure, right? Like things are really easier in the cloud, but you still need training, you still need expertise to build good systems in the cloud. And the cloud also adds new complexity in the sense that instead of having a walled garden of data in your data warehouse, you have like more of a data lake environment where a data lake may include a cloud data warehouse as well. Like you have a whole spectrum of data tools you can use, and now you have to manage and orchestrate those and manage the flow of data through that whole system rather than just kind of having it sitting in one place.
For sure. Yeah, Petri, I hope I'm pronouncing your name correctly. He asked, have you guys checked out the Velohi MLOps platform to manage ML development pipeline and manage models, versions, etc.? I have heard of it. I have not checked it out. So it seems pretty cool. There's a lot of these platforms out there right now. So it seems like there's new ones popping up all over the place. And then the clouds obviously have their, sort of standard fare as well. There's Vertex and SageMaker and stuff. But yeah, to answer your question, I have not checked it out. So I'm sorry. Yeah.
And you expressed an opinion on kind of a standard ML ops stack. What was your opinion on this?
Well, I think it's I've been chatting with some people in the ML ops community about this. I think because there's some notion that there should be like one ML stack to rule them all. I'm kind of riffing on this a bit, but I'm coming away with the sense that there really isn't. Yeah. So let's look at what I think, because there's the notion. What I did, I opened my big mouth and talked about the modern data stack versus the modern ML ops stack, which I said as a joke during a podcast, which should be out pretty soon. Okay. I was chatting with some of the folks over at Tecton about this. So the ML ops stack, or the modern data stack, right? Like that's really, I think, a progression of practices that have actually been around for decades. Yeah. Right? You're talking like a data warehouse, doing ETL developers, data warehouse engineers, and so forth. Really, that whole practice, you basically say, oh, you're going to use cloud-based tools now, modular tools. That's really the big difference. I think it's a lot simpler, but the underlying practices haven't changed. And so, but you apply this to machine learning, right? So analytics has been around for a really long time. It's a solved problem, right? The tools change, but the practices basically stay the same. You have things that make things, I would say technologies that make things easier, like dbt, but you tell me like what has actually fundamentally changed. There's more of a notion of ops. So you're borrowing from software engineering, but there's not really like a grand new nugget of an idea here. It's more of an evolution. That's fine. Hi. By the way, in case we're upstairs right now, because I'm expecting a bunch of contractors here. My
a lot of remodeling going on here.
Yeah, it's remodeling. I might have a kitchen today. So where was I? I think with ML ops, though, it's a bit different, right? So, you have different machine learning problems, computer vision, and where they work on different data types, right? So the notion that you need to use a feature store for everything is like, I think maybe there will be feature stores that handle unstructured data. I think there are a couple that are kind of early trying this problem out, but actually there are. Can't remember the names of them, but still, it's hard to pinpoint. Okay, so like this stack is going to work for every type of machine learning problem, right? So. So that's a bottom line of it.
And it's kind of related, and maybe we can put this comment up basically about the utility of deep learning. But like people get very, very excited about deep learning, but deep learning is really a highly, highly specialized technique that works extremely well on specific problems.
Yep.
And I would say that the efforts to create sort of general purpose deep learning tools that solve analytics problems have been, to say the least, uneven. Like there's been some progress, but in general, you kind of, like you're saying, you use different tools for different problems. I mean, deep learning really is amazing in what it can do, but it's also very limited in certain respects.
It is limited in certain respects, right? Especially when you get into non-linearities of structured data, it tends to kind of get a bit wonky. And so, I think that, as Petri says here, only a few companies really apply deep learning. Most are doing basic reporting or advanced analytics, and that's why demand for hardcore ML engineers is on the low side. And in his opinion, and I think we share that opinion too. It's just even applying classical machine learning methods. I would say, like we know one client that basically just uses logistic regression for everything, and like they very well have the capability of using something more complicated, but it's like something as simple as logistic regression works for their needs, and so this is what they use.
In fact, we've seen this, right? I mean, frankly, I've been on teams that kind of went in this direction. They hired PhDs, people like me, but PhDs who are much more specialized in deep learning. And those teams came in and worked on problems and didn't make a lot of progress with deep learning. And then they were able to make a lot of progress and generate a lot of value using more basic techniques. They kind of fell back on the more basic classical techniques that ultimately solve those problems. So, yeah.
Is it proper to call these techniques classical?
I don't know. Regression, I think of regression as classical because it's not even that modern. It's like just statistics, basically.
Yeah,
and
that's been around for how long now? Like hundreds of years or something?
Yeah, I mean, we teach a lot of regression techniques in calculus classes and algebra classes. Yeah.
But if you look at the math, I mean, the math behind a lot of machine learning, I mean, it's basically what? Probability and statistics, right?
Yeah.
Some calc, obviously, because you have to do gradient descent.
Yeah. Analysis, but that's calculus basically as well.
Yeah. And so, I mean, really tell me like, and there's obviously some new stuff going on, but that's why I kind of come back to the, first principles, understand the math behind what's going on. Because in a lot of cases, you'll realize, okay, so I could get away with just doing like simple squares of differences, basically, regression, or, basically being able to calculate distances. Yeah. That's pretty easy. Or I could do deep learning, which actually deep learning also calculates distances when you're doing back problem because you're just calculating an error.
Yeah.
So, but then, again, I know this because I've studied the math behind it, right? Like, I didn't just take for granted, like, oh, I can use this library and, and then everything's magically working. Like, but that's how I'm wired. So, also kind of weird in a lot of ways. So, that's like, yeah, I know.
I mean, yeah, that's why we're on here because we're weird, basically. So,
yeah,
we're doing.
Who the hell gets up on Monday morning and does this
after
this
Christmas?
Kind of
Yeah, exactly.
Yeah,
So,
masochist are you?
Yeah. But I think the other point I'll make is that even in the last 5 years, when did the deep learning revolution really happen? It's just really been the last couple of years that we've seen like a big.
Well, I mean, it kicked off 2013, 2014.
Yeah,
I remember
not long ago.
I mean, the grand scheme of things, it's not that long ago either, but it did change a lot of things. I would say for the better. Like it took, image recognition, and computer vision to a totally different level that you wouldn't have gotten. I mean, think, what was AlexNet or something like that was the first real use of deep learning to solve, an image problem back in the day. And, basically the scores were like 80% ish baseline. And then that kicked up to the 90s and then like 98% accuracy or something. Something that works really well for certain types of problems.
That's just it. And I mean, fundamentally, the way I understand it with image recognition, you kind of had all these different techniques that were jockeying for position. One would pull ahead, another would pull ahead. And then all of a sudden, deep learning just blew them out of the water, which that really was a revolution when deep learning pulled so far ahead in those media type applications with audio and video. But deep learning does have some major limitations. And I think fundamentally, we love to think that we can predict things because that's what we get paid to do. But fundamentally, there's a lot of unpredictable progress in this domain that's coming, and we just don't know what that's going to look like. And that's another reason why it's hard to define any kind of like MLOps stack, because probably 2 or 3 years from now, there will be some brand new technique. It could be brand new, or it could be some iteration on deep learning or something like this that will once again revolutionize the field.
Well, yeah, because people recognize, even the founders of it are recognizing the limitations of it.
Right. So for example, like GPT-3, all of these, language models have a memory problem. And by that, I mean that they're basically like a human with dementia. So they can compose really nice text, but they can't remember what they said 5 minutes ago. And they just can't do that at all. Whereas a human could keep various levels of history. We can keep that in our brains. We could say, okay, 10 minutes ago, I was kind of talking about this. Let's loop back to that part of the conversation. And so if you want to do something like write a novel, you need to have a memory so you can keep the thread of
Just use blockchain for that.
Yeah, you just use blockchain. Yeah. So I think at some point, like when machines develop that ability in conjunction with just amazing image recognition and text synthesis and everything else, then you're talking yet another big revolution. But no one solved that problem yet. No one has any idea how, as far as I know.
You bring up an interesting point too about prediction. I'm going to say it maybe in a different way. I always hear people talking about they can predict the future.
Yeah.
Right. I think it's hogwash.
Right.
So,
right.
But your thoughts on that, though? I mean, I think people over apply machine learning to certain things.
Yeah, that's an interesting question. I mean, I think if you want to understand forecasting, I think it's actually very useful to look at the Facebook profit, whole model system. A lot of people trash it routinely, which I agree it has limitations, but it actually works extremely well for what it is intended to do. And that is, it's meant to predict in domains where things are fairly predictable, if that makes any sense. So in other words, most years, the Christmas season is fairly predictable.
Right.
People behave in fairly predictable ways on specific holidays. You can look and you can take a profit model and you can match it to the data, and you'll see it uses multi-periodic techniques. In other words, it says, okay, I'm going to assume that in this data, I can have many different periods going on. I can have weekly periods and monthly periods and yearly, and these different trends that will repeat over time. And then it can also have things like certain holidays produce certain behaviors. I'm going to overlay that on top. It's actually, you actually get more value out of this type of model by being less sophisticated, because your more sophisticated time series techniques don't take into account a human calendar, human behavior, really basic things about humans. But here's the problem with profit, and with any of these techniques, really, they just fall apart when you throw a wrench into the works. And a wrench can be COVID, or this year it was like Omicron, where all of a sudden you have thousands of flights canceled because you have a huge spike in COVID cases that happens to coincide with the Christmas season, this big holiday shopping season right before the New Year's. That's where your models completely fall apart. And I think one of the problems with business in general is that we like to have one predicted model, right? We like to say, okay, this is our business forecast and this is our business plan.
Yeah.
When really we should have multiple plans to say, well, what if this happens? What if this
you
happens?
should do that.
Yeah, exactly. And that's not really forecasting. It's just like planning for scenarios or simulating different scenarios so you can kind of be prepared to come out on top regardless of what happens.
Well, time series forecasting, is that machine learning?
Yeah, see, that's an interesting question. I don't think
it is.
I think it's controversial.
I don't think it is, because I see data scientists trying to like get their test set and their train set and everything else. I'm like, you're overcomplicating it. It's a different type of a problem to solve inherently, right? So, Santa's calling Petri. Yeah, okay. See you, man. Have a good day. Guy Thompson, what's up, Guy? Hope you had a good Christmas. I see predictive analytics not necessarily being used to predict, but more to acknowledge predictions already made by humans from less sophisticated analysis. What are your thoughts on that comment?
That's interesting. I mean, to be frank, I see a lot of analytics being used in this way, and I view it as kind of a misuse of analytics, where business leaders who don't always understand statistics want a certain result, and so they just keep asking.
So why do you think that is? This need for certainty.
It's an interesting thing.
In an uncertain world.
Yeah.
Right.
I mean, we like to feel reinforced, right? We like to have our confidence boosted by having people use data to support the things that we believe. Yeah.
What are some anti-patterns?
It's an interesting question. I mean, specifically, I think if we as business leaders can kind of step back from our beliefs and ask more open-ended questions and look for statistics to challenge ourselves, we'll at least start questioning our assumptions and maybe assessing other possible business strategies. I don't know. What are your thoughts?
I think thinking in terms of confidence intervals and ranges, I think is something that's missing.
Yeah.
People want like the number, right? Mm-hmm. Like, is it 10? Right. Tell me the number. And I'll go off that. But it's not how the world works.
Right.
The world's very probabilistic. It's not deterministic.
Yep, exactly.
So,
well, and I mean, I think Soleb and others have pointed out for a long time that in the financial sector, people would use a kind of 99% scenario. So in other words, tell me roughly speaking, what would happen? Give me like a 99% band of what would happen. Well, the problem is that 1% band will happen. That can happen at least every century if you're saying 99% probability within a year. And that 1% probability could completely blow things up in a very catastrophic way.
As he also points out, these 1% probabilities, these once in a century things, they happen like every few years.
Right. So basically, that
your distribution is also wrong.
Your distribution is wrong
because you're assuming the world's Gaussian, right? And it's not. So
exactly.
Just a lot of misapplications. But that's why, as a data engineer, if you understand how things work, you can, I think, help add value for ML engineers, or especially if you're in a hybrid role, right, where you are the data engineer and the ML engineer and the janitor and everything else, right? So I think just understanding how things works does help.
Yeah.
So
okay, so here's a question. I mean, and I was thinking about this before I even got into data, but like, should we be getting back to more simulation, maybe? So I think there's a big focus on trying to predict the future, but should we just be doing more scenario simulation with a variety of scenarios?
I think so.
Yeah,
that's a really good idea.
Yeah, and one thing that springs to mind is, I think right before COVID, right, and you had been to Asia, you've been to various places, you've been around that area, and you're like, this could be really bad. I don't know if it's going to be, but it could be really bad. Yeah. And I think what happened with most of corporate America is they just kind of tried to operate with optimism instead, saying, let's just pretend that everything is going to be okay and operate according to that scenario, instead of saying, all right, let's have a plan for in case this doesn't happen, because maybe probably won't, but let's have a plan for in case the case where it does happen, and be prepared for that. And that's where simulation comes in, where you see data points to say, all right, maybe the economy is not going to function the way I expect it to, or maybe society is not going to function the way I expect it to for a while. Can I take that into account in planning scenarios and have multiple ways of handling things?
Yeah, it's like wargaming here.
Yeah, exactly.
Yeah.
Yeah.
The military does this all the time.
Yeah.
I don't know. They sometimes get the best results, but it's a cup for another day.
Yeah.
But yeah, simulations. I mean, that's definitely something you should be doing for sure.
And can you tie that into machine learning? I mean, if we can't predict the future, then maybe we can at least simulate a lot of different scenarios using modern modeling techniques, even advanced things like deep learning, and just kind of ask interesting questions about what the future could look like.
Yeah, it's a good question. I think like Monte Carlo techniques are taught in data science courses and math. So I think that's a good standby. Just do random stuff and see where it lands. Brownian motion. Don't assume that means you're going to understand like things like the stock market, though. We always see this where, people are like, oh, Brownian motion, well, random walks and stuff, right? So it's anyway, we talked about that in another chat.
Yes.
Yeah. Questions for the audience. So, what do you think about data engineering versus machine learning engineering? Like, where do you see the differences? Where do you see similarities? And what are your thoughts on it? So. Otherwise, Matt and I'll keep just blabbing out whatever.
Jabbering on all kinds of stuff.
Which is what we always do. It's Monday Morning Data Chat, right?
That's right.
So again, I mean, for the audience too, this is, Monday Morning Data Chat is basically like Matt and I just basically filming conversations that we normally have anyway. If it was not a camera here, it would be Matt and I just talking about literally the same thing. Yeah. So
this happens all the time, actually.
Such exciting people. So
predictive analytics being used.
Yeah, Guy says his favorite right now is predictive analytics being used with cryptocurrency. Can you elaborate on that, Guy? I'm curious what you mean by that. It reminds me of a talk that I gave about 4 or 5 years ago on time series forecasting, actually. And so I took Bitcoin price at the end of 2017, and I was like, okay, now watch this. If you took the forecast literally, it'd be like in the hundreds of thousands, given the trend that it was on. And then of course, I think a few weeks later it crashed.
Okay.
Right.
Yeah.
So that was sort of the punchline.
Yeah. But then where are we now? I guess the model.
I think 50s, mid 50s now. Or 60s,
okay.
Yeah.
Okay.
So yeah, it's interesting. But yeah, if you elaborate on that, Guy, I'm very curious what you mean with predictive analytics with cryptocurrency, because I'm seeing other people try this too. They're like, I want to do predictive analytics, like using ARIMA models to predict stock prices, to predict meme stock prices. And then I have another friend who told me about one of his friends who's taking IBM Watson and then combing Reddit, like Wall Street Bets, to get any signals to figure out where to trade. And so I don't know. I think it's interesting. I personally wouldn't do this, but I tend to be a bit of I don't know.
Yeah, I mean,
an old school guy.
Well, and I guess the point is that you just need to understand what your risks are, right? Fundamentally, this sounds like a modern version of an arbitrage play where you're just identifying some misalignment in the market for the way.
But what informational advantage would you have going on Reddit, though? You know what I'm saying?
I mean, what the whole concept of meme stocks is kind of nuts, right? And that's what people are taking advantage of. Like, people are just betting on random stocks based on, these Reddit threads, and they're kind of egging each other on to bet on stocks. And I guess if you understand your risks, that's okay. If you don't understand your risks, then you could lose a lot of money that you actually need or that you owe to someone else.
So Guy says non-utilitarian coins are usually just scams. There's a lot of people still attempting to apply stock market prediction calculations as something that's non-market dependent. Yeah, that's fascinating. Well, I think you'd be successful because you were lucky.
Yeah, until your luck runs out eventually.
Yeah,
that's the fundamental problem.
I can remember I saw this time series model once where it was basically just like moving averages, like multiple regression on each month, but there was no dependency on prior time periods, and so. I was like, this thing is not going to work. It's working because it's lucky, not because it's good. And sure enough, it blew up like a couple months later. And the customer was all like, hey, why is this breaking? And I'm like, I didn't make this, but I can tell you why. Because it's not supposed to work. It shouldn't have been built in the first place like this. So
yeah, and I mean, I think there's a certain degree of responsibility. Like there's an ethical obligation here to communicate with our customers when we build models to explain the risks that they entail, right? And anytime a model is being used to make bets, we have to explain to the people using that this could make the wrong bet for you, and then you could be out money. And let's explain, let's look at some scenarios where this may not work. So for example, if there's a correction on the Bitcoin market, then your model may predict an exponential curve that can't keep going on forever.
Right.
At some point, something has to correct. You might be holding the bag when it does.
You might be. With ML engineering too, say you built a giant stack for this prediction
Yeah.
too. You invested a lot of money into this.
Yeah.
If you're an ML engineer, how do you dissuade people from going down that path in the first place?
See, and that's the
Or
danger.
do you, because you have an economic incentive
Yeah.
to actually work and build this thing, whether it works or
Yeah.
not? Because you're the engineer, right? You're not building the model.
Yeah.
So that's what it's interesting. Incentives and outcomes, as we say. So.
Yeah. Well, because there's an incentive to just make the short-term bet, right? Again, we like to loop back to long-term capital management and Black-Scholes, but like everyone saw that bet was working. I'll have to go read more history about it, but I'm sure that there were people saying, look, this may not work forever. And when it stops working, people may be out a lot of money. It may cause major economic problems. But if you effectively have a golden parachute, and the golden parachute could just be that you lose your job, but you have savings and you're not on the hook for all the money that's lost,
right?
Then you don't have an incentive to like be responsible in this regard.
How does this apply to data engineering?
Yeah, it's very well. Okay, so bring it back to data engineering. Yeah, how does this apply to data engineering?
Well, I mean, you're building systems. I think this is a classic engineering thing, though, right? Where you're
Yeah.
building systems, to support something.
Yeah.
But you're the engineer, right? It's kind of like you're the construction worker building the house. Like you don't live there.
Yeah, you're one step removed, right?
Yeah, but you do. I think of the data engineering life cycle and the ML life cycle as well. You're still responsible for providing high quality inputs, right,
Yep.
for these models or for these analysis, and like that's what your job is essentially.
Yep.
So I think finding the best systems to do this, and so, but it's interesting.
I think there's a tendency to just say it's someone else's problem. Like I just created the data, you decide what you do with it. But I don't know if that's the right approach.
Hey Matt, he wants to know why you're a recovering data scientist. Good morning, Tiago. How are you doing? I think we both call each other that.
We definitely do, and I mean, fundamentally, is it partially just a matter of the experiences that we had? But I think they're experiences that aren't all that uncommon.
No, I don't think so.
Yeah.
I've been working in machine learning for a while now.
Yeah.
I mean, it's 10 years. So I would say that my experience, I'm probably going to echo you, but it's like I think a lot of people just start out with doing data science and don't really think about the why or the how and what they need to do it. And so they build these models that basically reside on laptops, and we try and productionize them. It just falls apart. I realize basically machine learning, to do it right, means it's an engineering problem. Right. So I don't know, what's your experience?
Yeah, I mean, my experience was similar. I mean, I was brought in to try to solve some, well, honestly, we weren't really given problems to solve. We were just told, you're a new data science team, produce value. And that didn't really work very well. And we also just didn't necessarily have the tools that we needed for production use cases. And so I ended up kind of wandering onto the data engineering side for that reason. And then also just coincided with the real growth of data in the cloud. I mean, it's not like EMR or even tools like BigQuery and Redshift were brand new, but it was just the time when everyone was getting into those tools, realizing how much you could do with off-the-shelf cloud products. And so that made it very attractive to get into data engineering because you could jump in and produce value.
Well, you had a necessity to do it, because if you didn't do the data engineering, you wouldn't be doing your job as a data scientist, right?
And it's like at some point, well, I'm the specialist now, which means that I'm actually not a data scientist anymore because I'm the one who produces the data.
I think also it's just recognizing when you zoom out, you start seeing these problems over and over and over again, where companies will hire data scientists or data scientist teams, and expect them to do machine learning, and then they're like, well, why haven't you guys produced value yet? Right. And so inevitably it ends up being an engineering question, at least in our experience. Again, this could be self-selecting, but I don't think so. We see this enough. So there's lots of data scientists all the time who are hired to do magical things, and they end up waiting on data and maybe building systems to get the data, usually in a very haphazard fashion as well, because they're not trained to be engineers, right? They're just doing what they can to do their job, and you can't blame them for that. We've all done the same thing.
Well, and I think when we think about the notion of cargo culting, just like trying to copy what other people do to be really successful, whatever happens to be hot, I think one of the companies that gets cargo culted the most for good reason is Google. Like everyone saw Google doing these amazing things with data and not realizing how much work they put into having really good systems behind the scenes. Like at Google, as far as I can tell, the vast majority of their effort is going into data engineering. And then they get amazing results out of data science because they have such good systems.
Yeah, it's all about the data at the end of the day, right? Yeah, and ops, that's a big one, right? So you're starting to see data ops. And that's been around for a bit. ML ops is, definitely the hot thing right now. So if you're going to get into data science, I'd say look at ML ops, look at ML engineering too, and maybe transition to that. I think because the notion of like modeling and all that, like training models, it's very much a solved problem, I'd say, for most use cases. It's not an interesting conversation anymore, at least for me. If you're an academic research on the cutting edge of training, I think that's cool. Like we talked on, it might be whatever successor is to deep learning.
Yeah,
but
we'll have to bring Aaron Hunsaker on sometime. He works for he's part of Ternary, one of our senior engineers, and he's talked about the fact that what often happens now in a machine learning career or a data science career is that you kind of build one model and then you'll spend like 5 to 10 years just like tuning that model all the time, right? Because now you have a machine that's working, right? So now you're in the engine room.
A money printing machine.
Yeah. It prints money, but you got to retune it all the time. It can turn into kind of a boring job, actually, because you're just in there like turning knobs basically to keep this model running well.
All jobs get boring after a bit.
Yeah,
right.
I suppose so. That's maybe just a sign of maturity. Like we're not doing cutting edge research in laboratory anymore. We're just using interesting tools, but we use them in a very predictable way to get very predictable quality results.
Emery says, "You activated my Google Home." Hey, Google. Sorry, man. It's a service we provide. Actually, right here. I have an Alexa, which I just turned on. Yep, she just turned on, and then I Google actually in the other room. So sorry about that. Totally empathize.
I have none of these devices. I mean, I guess my phone can be voice activated, but I'm like, hey,
yeah, but Siri is like the worst.
Yeah, on my watch. Yeah, she
so
turns
dumb.
Turns on all the time.
It frustrates my kids too, because I'll talk to Siri and Alexa asking questions for school.
Yeah.
That's the other thing. Kids ask, use these devices for school now. It's just kind of interesting. Talk to robots and stuff, but the voice recognition is very hit and miss. They'll be yelling at Alexa, like, Alexa, why are you so dumb? I'll just look this up on Google.
The other problem with Alexa and with most of these systems, frankly, is that they have sophisticated voice recognition, but it's this memory problem, right? So when you talk to Alexa, how does it think about state? I think this has improved, but a few years back, this is how it worked. You're basically talking to a sophisticated phone tree. So behind the scenes, you just had a hierarchical model of different states that Alexa could be in. And you say, all right, now I want to ask this question. Then it would respond.
Yep.
And everything it tried to respond to thereafter was from the perspective of that state.
Yeah.
And it couldn't keep track of a longer conversation. It was very hard to get it to loop back to thinking about the recent past, for example.
It's impossible. Actually, I made one of the first published Alexa apps back in 2015 or 2016.
Yeah.
I still get AWS credits for that, surprisingly. Thanks,
awesome.
AWS. For being an Alexa developer, far removed. Nobody uses my app anymore. But yeah, that's right. It would just be basically a series of states, and it's very hard coded at the time. I'm sure it's improved. It had to have improved. I hope it's improved. It's kind of kludgy back then.
Yeah.
So,
but I mean, I think even there, if you could solve that problem, then you would just blow everyone away. I think you would take over the space very quickly.
That's probably GPT-3.
Yeah, well, except again, GPT-3 also has a memory problem. But yeah, if you can figure out how to take GPT-3 and give it a memory somehow of the recent past, then you're talking.
That'll write your charm paper for you.
So yeah, exactly.
Yeah, interesting. Let me see. Actually, there's Tiago has a question here. So, statement really.
Yeah.
So every data scientist that joins a company without proper data engineering has a 95% probability of ending up as a data engineer. Sounds like the same experience of a bunch of people. Yeah, I think this is kind of the common convergence. I don't know if this ends up being like a law of some sort at some point, but like a Moore's law.
Yeah.
But
we try to pitch people on the idea of investing in data engineering first. It doesn't mean you don't need data scientists. It doesn't mean you don't need sophisticated tools, but like build the foundations first and get your data in place. And often they'll find a lot of value just out of better analytics or more real-time analytics. And then they can focus on these harder problems once that foundation is there.
Mm-hmm. Yeah, for sure. Yeah, good insight. Guy says for a long time, and probably still today, data scientists weren't necessarily building out data systems. They were usually just going and grabbing the data they needed for the use case. Yep, that was me back in the 2000s. I would just get the data I needed, hope it was right, and build things. So,
and a lot of ML ops is not anything particularly sophisticated. People are still fighting over the exact definition of ML ops, but it's just getting models off of laptops and getting data pipelines automated. That's
just like you do in software engineering, right?
Exactly, or data engineering.
Observability is a huge thing right now in ML and data. Yeah. So big one. For sure. But yeah, data systems, it's like, these didn't exist back in the day. You would just say, I need to go get that file over on that SharePoint.
Right.
And just do it that way. So it was a simpler time.
It was, but it's also funny that we kind of threw out the baby with the bathwater. So you had things.
Well, who's the baby and what's the bathwater?
I think in this case, maybe the analogy is misused here, but basically what I would see is you'd have a nice data warehouse with fairly curated data. And people would like download, they run a SQL query on Teradata, they download some data, and they build a sophisticated model off of it. And that step of like, you already have automated data pipelines, and so you should be able to automate that kind of last mile part of training your model. But that part wasn't happening,
How often would those models end up just being the same thing you could do with a report?
Yeah, that's a very interesting.
I've seen this a lot. Like you build a model and it's like literally like you could have just done that with a group by your k-means that you're doing. So, yeah, it happens.
Yeah.
So
even some of these like trending models, you could often see the same results just by doing a group by and an order by, and just seeing what the top results were in searches, for example.
Yeah, and I think BI data for machine learning is a bit of a misnomer, depending on the type of problem you're trying to solve. So highly structured data actually answers its own questions.
Yeah.
So often,
and then you apply some enhancements to it, but like you often don't need really sophisticated techniques
or machine learning at all, frankly.
Yeah.
So
should we talk about this?
One second here. Warren Buffett, just kidding. Warren Buffett said something to the effect that if investing is exciting, then you're doing it wrong. It seems like once professionals get into the groove, excellence gets a little monotonous. Yeah, that's true for sure.
Yeah.
So,
well, and how much of your responsibility in investing comes down to protecting investments versus trying to make a lot of money? Because again,
Warren Buffett's rule 1 is don't lose money.
Yeah.
Rule 2 is don't ignore rule 1.
Yeah.
So it's that easy and that hard, right? So I think. Again, I'm definitely a Warren Buffett fanboy. I actually have a few of his stuff laying over there. But I think he's got a lot of good points too. So just about, I think investing for him is just more about emotional control. Mm-hmm. Just if it's boring, it's probably a good thing. So, but I'd say in a dynamic world like this, though, things just I think change more quickly, but the fundamentals still stay the same.
Yeah.
So,
well, like in the data space, I mean, to be quite frank, there's so much money floating around, and there are so many people chasing money, VCs, investments, and things. It's an interesting place to be. I don't know quite what to make of it. I mean, you've been following investments for a long time, so you might have some opinions about stuff that's happening.
Frankly, I have ideas,
dynamic,
and opinions, but I try not to share them too often. So it's what it is. Yeah. Tiago asked, "What are the plans of Ternary Data for 2022?" I think that's a good question.
Yeah.
Our consulting practice is growing a ton. So we'll be growing out that team. I think additionally, though, with this thing called the Fundamentals of Data Engineering, this book we're writing, it's going to open up a lot of doors for us, right? Both for consulting, I would say, as well as courses. So we're actively working on I think basically the first data engineering course that really, I think, covers the fundamentals. I think there are other courses like that, but they focus more on tools. I think we're trying to stay away from that and really focus on like, what do you need to know as a data engineer, being tool agnostic, right? So that's going to be a big one. Pushing more into contents, another area. What else have we got going on next year?
Yeah, I think that's going to be a lot of the focus, frankly. I think we do see a lot of good content out there, but we do see areas where we can improve upon it. And that's what we really want to focus a lot on this year, especially because so much of our consulting practice has been helping data engineers to skill up in various ways to learn to use new tools, but also to have a better sense of the entire domain, like you were saying. And so kind of full life cycle thinking, as opposed to thinking about Spark or just Hadoop or just Peg or one.
Yeah, those conversations are interesting, but they kind of bore me at the same time.
Yeah.
So equating like, learn data engineering by learning Hadoop. And it's like, nobody even uses that anymore anyway. So
it's just a component, and you're not going to interact with it that much directly, right? It's in EMR, it's in Google Data Proc, but you're not going to be like building
or learning data engineering by learning EMR, right?
Yeah,
to me, that's not
exactly.
even an interesting discussion.
That,
So I think those are some of the plans for sure. Definitely going more content heavy. I think the book. It's funny because that was originally the plan for last year. Then the book sort of sideswiped us because running a business, growing a business, and writing a book, I would say, is not for the faint of heart.
I was at a family Christmas gathering on Christmas Day, and I was like the one sitting at the counter writing the book.
Same way. But people understand, right? Maybe
they do. I mean, I still.
It's Matt. He just does this. He's fine.
But soon the book will be done. We're very excited about that. We really appreciate the support we've gotten from O'Reilly, and also the support we've gotten from a lot of our early readers.
Yeah, a lot of people
reading the pre-release on O'Reilly. That's been awesome to see the support and the value people are finding in it. And we're really trying to shape it to make it useful to both current and future data engineers. And the content is intended to build around that. And some of it will be tool specific, but I think our goal It's not so much to like eliminate all the tool specific training. It's more to say data engineers also need to think about the bigger picture.
Well, then they also tell you how to select tools. Right? That's something that's really missing. Is like, because when we started thinking about what to write, we're like, okay, so what's not going to change in the next 5 years? Or 10 years? Because the common complaint we got was, well, how dare you write a book on data engineering in a field that's changing so quickly? I'm like, that's a fair point. So the way you go about that is think about life cycle, right? You don't think about how does Spark or Dask or whatever fit into the picture. It's like it's a meaningless conversation because until you understand the life cycle, you actually don't know how to fit anything in. You're just getting tools.
That's right.
So,
and I think watching some major transitions happen in the data space has helped to inform us about the things that aren't going to change. That is, we're going to see more managed services. The services are going to get simpler and more accessible, but the hard data problems of like ensuring data quality and monitoring and creating data that's useful to the people you're serving it to, those are not going away anytime soon.
Amiri asks, when does the book come out? It comes out, I think the pen date is September 2022. It might come out earlier, actually.
We're hoping.
Stay tuned on that. We really wanted to get out, and Guy's been actually helping read it a bit. He really enjoys the narrative in the new book. Lots of O'Reilly books can be a bit dry, but Fundamentals book comes off very approachable. Thank you for that.
Thank you. Yeah, that's awesome.
Yeah, and I'd say for anyone who wants to check out the early release chapters, go to O'Reilly.com. And it's there. Leave a good review if you like it. But again, expect more in this space, and content I think is a natural evolution of where Ternary is going, kind of back to Tiago's question. So, and why are we open about this, right? We could just be very, I think, closed vest about it. The thing I've realized about content, especially, is content is not a zero-sum game. Right. So just because, some of our friends write data engineering courses doesn't mean you can't get both, right, and get different opinions. If you look at our bookshelves, they're full of books. How many people out there have like one book and only one book? Nobody, right? Or maybe you do. I don't know. Maybe you like that, but you would never do that. You say, well, I can only have one book, and that's the only book I can ever have, right? This isn't like a punch pass or something. So knowledge is one of those things that I think is just very multiplicative, and so that's why I have no problem talking about our plans, because even if you try to come up with a data engineering course, it'll be your course, right? And it'll be different than ours. And I think that's great. We have our own take on stuff. We have our own opinions, and whoever makes their own content has their own opinions and approaches too. I think that's a great thing in the world. If the world is homogenous and we had to stick to a certain standard, that'd be boring as hell. So, and consulting is the same way in some respects. I think consulting very much is a zero-sum game, but it's like the way we do things is not how anyone else would ever do them. Right. So it would be impossible to replicate. And that's why, again, it's like, we can tell you what our plans are, but it's like, for you to come in and try and replicate it is next to impossible, because the company's born from our own experiences and what we've been through. And it's like, that's every company. So, and the fact we're not dealing in a commoditized area means that, it's impossible to knock off.
Yeah. And I think the whole key to a content play, and I think many people who have tried to get into content, both in tech and many other domains, have found this, is that if you try to go head to head with really successful people, you're going to fail, right? It's kind of idiotic to just try to take on the biggest trainers in a certain domain. It's not a good idea. But what you can do is identify what's missing. Like, what are people not finding right now, and focus on that instead. And I think that's what we intended.
Content's also interesting in the sense where there, again, back to Matt Turek's giant slide, the data landscape, right? So one option for Ternary was to just do a data startup, right? Why didn't we do this? Not to say we won't, but
we'll see what happens.
We'll see what happens. But the thing is, like, where are you going to find a specialty in a landscape that is crowded in tools right now?
Right.
And are you sure that you pick the right tool and the right problem to solve it? You can dedicate the next 5 to 10 years of your life focused on that. You could pivot, of course, but the grain of what you're trying to solve still needs to be the same, I would hope, or at least in the same vein. And so I just don't know that I'm smart enough to figure out what product to build at this point. Whereas content is interesting because you can just, capitalize on the latest trends and make content on that instead. And I think that's, to me, a bit more interesting to solve right now. Well, we're trying to figure out, maybe what a good data product is. I just simply don't know. I don't know that I'm smart enough to know that answer.
It's really tough too, because to be quite frank, we see a lot of startups kind of stepping on each other, doing very similar things. And
observability is a big one.
Observability is a big one. I think it's super useful. But I don't know who's going to win the game. And it's tough because many of these companies, some will be super successful, some will get purchased, some might get crushed by the big players. Like, it's a scary place to be. I wish them all success, because all they observe.
A lot of them are friends too. Yeah, so I hope everyone does great. You know, but the thing is, it's like everyone doing great means nobody does great, because again, business is very much in that space, very much a zero-sum game. Yeah, and so it's like now you're
capture.
Yeah, it's about market capture. You know, and it's like if you get a first mover advantage or a fast follower advantage too, then you can win. But it's an incredibly difficult problem to solve. Like if you look at the data landscape and ask me who the winners are, I don't know. Yeah. So you know, a lot of it depends on the teams. Honestly, you talk to VCs, that's how they invest. It's not the idea, it's not the product. It's like who's the team behind this? Yeah, because you have so much uncertainty. It's like how can you assess what field is going to be dominant either? So.
It's their ability to like make adjustments to the current realities of the market and to just really promote and grab market share. That's a very tricky problem, and I don't think anyone is really certain how to solve it right now, to be quite frank.
If it was that easy, it'd be you'd have the efficient market of startups.
That's right.
You have the exact
it's
opposite.
Not efficient at all.
No, it's totally inefficient, which is great. That means awesome. If it's inefficient, that means there's opportunities, to make a dent. Where if it's totally efficient, then it'd be like, well, then what's the point? You just get the index of startups and you're done. So maybe somebody should do that too. I don't know.
Maybe so, like startup analytics.
Super sketchy. But yeah. So anyway, it's time to wrap up now. But thanks to the audience for the questions. Sorry, Luigi couldn't make it today. Again, he was feeling a bit under the weather, so maybe he'll be back on at some point. He's a really cool dude. I need to talk to him about jiu-jitsu as well. We're kind of nerds in that area.
Oh, so, nice.
Yeah.
I don't like getting hit. So
in jiu-jitsu, you don't get hit.
Okay.
Yeah, it'd be perfect for you. So you just you can go 100%, just grapple, and no, it's all submissions.
Okay. See, that sounds terrible too.
No, it's fine, man. It's fine. It's totally safe. As long as you tap.
So, yeah, exactly. You gotta tap. Yep.
Yeah, I was rolling with one guy. I don't know. It's weird. I think I wasn't sure he wanted to break a limb or something because he wouldn't tap on anything. I'm like, I can't force you into this. I can't go any further. So I'm gonna hurt you. So it's a weird sport. It attracts some interesting people. But yeah, and if you're in Salt Lake too, I think I'm gonna be getting back into jiu-jitsu pretty soon. Probably around February ish. So
if you want Omicron allowing, we'll see.
Omicron allowing, yeah. I think once get past a few other things, and I'll be back on the mat. So if anyone wants to go do jits, let me know. So and awesome. Anything else you want to cover? Or are we good? So kind of a roundabout discussion. Enough of us. Yeah, data engineering versus ML engineering. It's a good chat. Kind of roundabout. If anyone in the ML engineering or ML ops world wants to be on the Monday morning data chat as well, let us know. We'd love to have you on and chat about it, because I'm very fascinated by the space right now. So, and if you haven't done so, please subscribe to our YouTube at Ternary Data. You can also get our newsletter at ternarydata.com. Every week we publish our weekly data rants, which I think a lot of people like those. So
yeah, they're kind of trolly, frankly, very
sometimes,
but they're fun.
Yeah, I think a lot of people like them, because I think what's missing is you can send out, and it also includes links. But I think the cool thing with what we're doing is just very off the cuff, our thoughts. It's basically Monday morning data chat written down, frankly. A lot of people like them. So if you want to get that newsletter, subscribe there. Right now, the only way you can get the weekly data rants is actually to subscribe to the newsletter or have them forwarded. We've heard people are forwarding them, so it's kind of like this underground mixtape thing now. And then what else? We got some events coming up. Actually, next week we have Seattle Data Guy. He's going to be on, so he's always fun to talk to. So we can talk about data engineering with him. Then we also have who else is coming on here? I know Andreas Kretz is going to be on later in the month. 1 second here. I know there was Kevin Hu. He's going to be on the show on the 10th. That's going to be dope. So he's a CEO of Metaplane. He's a really nice guy. We spent a nice afternoon walking around with him in Boston.
Yeah, very insightful.
Yeah, very smart person. I can't wait to talk more with him. Yeah, and so a lot of stuff coming up. Also, if you're in the Salt Lake area, we have I think it was the 25th. We have a happy hour with Starburst. So they're going to be sponsoring a happy hour. So hopefully, COVID notwithstanding, this should be a fun time. So this is also during the Sundance Film Festival. So, if you're into Sundance Film Festival, let's hang out. So
yeah, let us know if you're in town.
Yeah, let us know you're in town. Yeah. So cool. I hope everyone has a great new year. Can't believe 2022 is already rolling around, but I guess it's what time does. It just marches on.
Especially when everyone's in isolation, trying to figure out the future.
Yeah, right. So, yeah. Awesome. Well, cool. Well, Matt, I guess we better get to work. So hope everyone has a good Monday. We'll talk to you soon. Bye-bye.